on even and odd functions. Okay. So we're going to learn how to tell if a graph is even or odd, and you'll figure out in a minute more about why it's even and odd. Okay, a function is even if the graph has symmetry around the y-axis, or you could say over the y-axis. Write that down real quick. A function is even if the graph has symmetry over the y-axis. So a graph is even if it has symmetry over the y-axis. So let's look. Meaning, if I fold it over the y-axis, it should land on itself, correct? Oh, let's finish our notes, though. Sorry. A function is odd if the graph has symmetry around the origin. We call it rotational symmetry. And it's rotational by 180 degrees. If I turn it 180 degrees, it should land on itself. So get that one written down in your notes as well. We got them all? So let's look at the graphs. Let's look at the graphs. Sorry, I'm multitasking here while recording. Determine if the following graphs are even, odd, or neither. Okay, so if I fold this over the y-axis, would it land on itself? Number one here, it would not land on itself. If I put my pencil right here at the origin and spun it 180 degrees, would it land on itself? Yes, this would land back down here. So this is an odd function. This function is odd. It's categorized as odd because if it rotated around the origin, it would be odd. So if you want to just draw a little sketch of that, you can. It doesn't matter. It's going to be pretty easy. You'll probably be able to figure it out. What's the next one here? Even or odd? Because it's an even function because if I folded it right here down this y-axis, it would land on itself. So this is called even. What about the last one? Even, odd, or neither? If I rotate it or fold it, it's neither, right? So that's really, really straightforward. Okay? Very, very straightforward with that. Question. If I offset this parabola, even, odd, or neither? Now it's neither, right? Now it's neither. If I fold it over the y-axis, it would not land on itself because folding it over would put it over here, correct? So that is not even. If I rotate around, it is not going to land on itself. So this is now neither in this situation. Okay? Let me see what the next page says. Okay. Before we do the next page, I want to teach you about the next page. Think this through. If a function is even, that means, tell me about the y value based on the x value being, I didn't word that very well. Tell me about, let's go to this parabola that we said is even. Tell me, what is the value when x is 2 on that parabola? When x is 2, what's the value of y? 2. What's the value when x is negative 2? What's the y value when x is negative 2? 2. So that's the same on both sides, which, by the way, is why it's even, right? Because if the y value wasn't the same on the negative side as the positive side, it wouldn't fold over and wouldn't have symmetry down the y-axis. Do you understand that? Okay, so every time when I find an x value on the right side, or positive x value, the y value that corresponds with that will be the same y value as the negative x value. You see it? What I'm saying? Okay, so what is the equation of this parabola we have right here? Y equals x. There's no shift left or right, so x squared minus 2. Do you agree? It didn't shift left or right. It went down 2. That's the function. Okay, so when I plug in, what you're telling me, or what we just figured out is, if the x were, think of this as a positive number, if I put a negative x in there, what happens to that equation? Did it change? Why not? A negative squared is a positive, isn't it? A negative x times a negative x is still positive x squared minus 2. You see what happened there? So in other words, even if I plug a negative x into where the x was, I still get the exact same equation out. Do you see that? Okay. Let's see what happens. Let's see what happens over here. What's the equation for this? X what? It's almost x cubed. We better not use that one because it's hard to tell. It's almost x cubed. Let's use x cubed. What would x cubed be? Would it just been here and here, right? So it looks like x cubed. It's probably got some little bitty stretch on it or something. So let's take y equals x cubed. If I did the same thing and put a negative x in place of it, do I get the same thing out? Is negative x cubed still positive x cubed? It's not. Is it the complete opposite? Is this the complete opposite of this? Opposite meaning the sign changed. Yes. So when something turns to the complete opposite in an equation, that shows you it's odd. Now I know you're confused. What are we thinking? Where are we going with this? Here's where we're going. I'm going to skip the first one now. Let's go to the middle one. What you're going to want to do, and I'll let you write this down in a second, is, well, actually, I changed my mind. Let's go ahead and write it down. You're going to be able to figure it out from what it says. Go ahead and write those notes at the top. Write those words at the top. I'm going to pause the video. So what it says here is, a function is even when you put a negative x into the original function. In other words, when x and negative x are plugged into the y values are the same. In other words, when I plug in a negative x into the function, it's going to be equal to the positive x version. That means it's even, just like we showed you on the last page. Okay, well, how do I know when something's odd? When I plug a negative into the x, and it comes out the complete opposite of what it was. Do you see how that's saying it's the negative, meaning the complete opposite of the original? That's when it's odd. Can somebody process why that is? Process why that is. Why is it that when I plug a negative in on an odd function, I end up with a negative version of the function based on what you just learned about rotational symmetry? Think it through. Why is it on this odd function? Let's go back to, let's take this point. Let's pretend that's a good point. Positive 2, positive 1. What's the negative 2? Negative 1. Do you see how it's the complete opposite? Because when something's going from the first quadrant to the third quadrant, what happens to both the x and the y? In the third quadrant, x and y are both what? Negative, right? So you took two positives and made them the complete opposite, two negatives. X and y are positive in the first quadrant, and to have rotational symmetry, it would have to land from first quadrant into third, and so it would have to both be negative. Okay? If it went from the second quadrant rotationally, it would have to end in the fourth, which would mean negative x, positive y became positive y, negative x, right? Here, let's look real quick. Oops. Okay, this is a what function? Rational. We've been studying that. Thank you for being able to say that. Rotational symmetry. This is a little bit slow. Rotational symmetry looks like this. Is it going to have rotational symmetry? It should, shouldn't it? Because it's 180, not 90, 180 degrees rotated should give rotational symmetry. While that's doing that, I wonder if I can write on this while that's doing that. Y equals 1 over x. If I change the y equals 1 over negative x, is that the complete opposite? That is the complete opposite, right? Because it went from positive 1 over x to negative 1 over x. Therefore, it should have rotational symmetry. And if we have enough time during this period, we're going to see it land on. We're almost there. Boom. That's rotational symmetry. Okay. No, I think it stopped. It didn't. I'm not going to do it again because it took so long, but this one went to this one. It just took a while. Okay, let's look at a reflection. This one's kind of weird. It comes to the middle and flips over. So it is not an even function because when it reflects over the y-axis, it does not land on itself. You with me? Okay, let's try another one. Let me reset that for next period. Let me clear. Okay. Now, this, you don't know it yet, is called a cosine graph. Did you do that a little bit last year? Cosine, sine, and cosine. That's a cosine wave, okay? What do you think it has? Even or odd? What type of symmetry? You think it's even? So I need to do what? Rotate or reflect? Reflect. Right? Okay. If I rotated, this one's a little faster. Mr. McGann's pretty cool. This is all Mr. McGann's making. He's very technology efficient. I can just use it. I can't create it. So this is not going to work. Why not? And basically, tell me about, well, I'm not even going to finish that sentence because it's not true all the time. So. Okay, so DNA. Looks like some DNA. So that didn't work because it didn't exactly land on itself. Okay, so here we go. Let's go back to where we are. So we're working on this middle one because it's a little easier. I'm avoiding the absolute value for now. So I'm going to take the function and I'm going to insert a negative x. I'm going to change. You do this every time, Nick. You take your positive x and make it negative. So here we go. Negative x minus negative x cubed over negative x to the 4th. You see it? And now from here, it's just thinking about it. Thinking about your math. Madison, why don't you go get a drink? Okay. So f of negative x equals, what would it equal? Well, it'd be negative x minus, what would this be? That'd be that'd be negative x cubed, which would change, and so we're going to end up with a plus there. You see it? You see that? Over, what is 4 negatives would turn out to be a positive. So that's going to be x to the fourth. Okay, let's compare. Did every single part turn to the opposite, or did it turn, is it still equal to itself? Well, obviously the first one is negative, so this is opposite. So it's no longer even because one part of it's the opposite, so it's not even for sure. But it's only odd if every part of it worked. That changed. This changed from minus to positive, so that changed, but what happened here? Okay, so it's not the complete, actually, let me think that through. Everything has to change. Hold on, nope, let's think this through. Let's factor out that negative on the top. Let's factor out a negative. If I factor out a negative, what happens? X minus x cubed, do you agree? Is that what that is? So we got to be careful. So we factored out a negative, and it's the complete opposite, isn't it? It was a positive, and now it's a negative. Do you see it? If it were negative on the bottom, what would happen? A negative and the negative would turn back to a positive, and this would be even. If this were still negative on the bottom, this negative and this negative would cancel each other out, and it would switch back to positive. You with me? So let's put it in the calculator. Did y'all get calculators? That's okay. We'll do it. You can do it later. Trust me. For now. Okay, do what would be number 3, I guess. Try this one by yourself. I'm sorry. So this is odd because it is the opposite of what it was. That is odd because it's the opposite of what it was. Even though the bottom one stayed the same, we needed that for it to be odd. Okay, try the next one. Did you get that? Okay. I'm going to take a moment to get my calculator going here. So even, odd, or neither for that? I think it is. I just squeezed it in. X squared. Negative squared is a positive, and those two negatives make a positive. So we're going to say that one's neither. Okay, real quick. Let's go back and look at both of these. Okay. Okay, what was the one we just put in? The original question. Does anybody have it written down? 4 divided by, open parenthesis, what? X squared minus 7x. Close. Okay, graph. Oh, yeah. That's got to be neither, right? That's crazy. That's neither. I couldn't fold that or rotate that and it work at all. Michael, why don't you go right at the end of class after I finish my lesson? Okay, so let's go back. I got this other one in the calculator. What was the one before? X minus x cubed over x to the fourth. No. X, what was it? X, I need parentheses though. X minus x cubed, close, divided by, hold on. Delete. Divided by what? X to the fourth. Yes, I can. Hold on. I got to correct a lot of stuff. That parenthesis I need to delete. I need to get down. I need to insert a close. Is that better? Now it's going to not like the fact that I have it. Oh, there we go. It fixed it for me. No laughing at the old teacher. X. Is that right now? Okay, graph. Graph. You're laughing at me. Okay. Now think about that. We said it was odd, right? If you put your pen in the middle and flip this around, would it work? Large screen? Yeah, now let's see how fancy I am completely. Oops, I didn't mean to do that. Hold on, clearly not that fancy. I want to make this smaller. Okay, hang on. Hold on. Where's this? Oh, y'all don't know that you're about to be impressed. Ah, yeah, see, I did it. Okay, so if I rotate that around, it looks just like it, right? Was that not kind of impressive? I just took the graph on the calculator off onto the screen. Oh, well, I don't know how you copy on the calculator. I don't think it has that thing. You have to drag it over. So anyway, so rotational, that was here. That's this graph. Okay, let's look at this last one. Let's look at this last one. F of negative x equals negative absolute value of negative x over negative x to the fourth plus 3 times negative x squared. If. So what's the absolute value of negative x? Is x over is positive, right? Plus 3x squared. So it's the same. Make sense? We good? Okay, one more thing. Then we're done. Okay, you don't need to write anything on this. You can just watch and then you'll be able to do it on yours. Make the following function even. Make it even. Okay, let's think about this. When a function was even, no, if the x were positive x and negative x, the y was the same. Okay, so you could come and draw it probably first, but let's try to do this. So if I have x, if when x is 1 and y is 3, then when x is negative 1, y is still 3. When x is negative 3, y is still 1, negative 4, 4. You seeing it? Now let's graph it and make sure it works. Negative 1, 3. I even have the same color. Negative 3. It's the little things. Negative 3, 1. Negative 4, 4. There we go. I'm not as funny when I'm not recording. Y'all are thinking this is funny that it's on a recording. Is that good? Let's see if there's another page. Here we go. Last thing for the day. As if y'all are going to watch this later. Y'all heard the lesson. You got more to do than that. Okay, here we go. What if it were odd? What the x? You have to change both. The x and the y would change to get it into the quadrant that's across. So this would be 2, negative 1, 3, negative 3, and 4, negative 2. Okay, so here we go to graph those. 2, negative 1, 3. What? It's kind of hard to graph. Ugh. So it's going to go up this way? Is that right? good? I don't think I can spin it. We could check though, couldn't we? This would be, wait, 1, 2, 3, 4, 5 is 1.5. 1, 2, 3, 4, 5, 1.5. Yeah. Oh, should this be bubbling out? That one should bubble out. Yeah, because they go in towards each other. So these have to come in towards each other. You're right. It's kind of hard. Are we done? We're done. No, you may not. But think about it. Okay. We can stop this recording, put everyone.